In the next example, we are going to see a program that obtains interesting information from the operation system. The next program is date.asm. Let's begin by assembling and running this program to see what it does. We open the console, and next we assemble and run this program. This is the output of the program. The date is followed by the date, and then another line which says, "Have a great day." After writing those two lines, the program has exited. Let's try again. We get basically the same output, maybe because the date hasn't changed. Let's take a look at the code. This is date.asm. Let's begin by taking a look at the import section. The iData section is the import section of this program. We can see that this program will be linked to the files kernel32.dll and also msvcrt.dll. The library macro is followed by two import macros. The first one specifies which functions we are going to use inside kernel32, which are the functions exit process and get system time. We also make use of printf from the module msvcrt. The new function in this program is this one, get system time. This is a function which we haven't seen before, and it resides inside kernel32 module. Let's see the data section. It contains one string. The date is followed by 3 format specifications. All of them are for decimal numbers. Then we have a new line character sequence, followed by the next line, "Have a great day," then a new line, and finally a zero terminator, which means that this is one string. It just contains 2 lines. Let's continue now to the code. The program begins by calling this function, getSystemTime. It is given one argument, which is called systime. We can see that systime is declared inside the BSS section, and it is some kind of structure, a structure of type systemTime. Note that the function is given the address of this structure in memory. Next, we have a call to printf, which is on this part of the code. Printf here takes as a first argument the string sdate, which is exactly the formatted string we have seen inside the data section. Next, it takes 3 more arguments. That is because inside sdate there are exactly 3 format specifiers. We can see that those 3 arguments are taken somehow from inside the systime structure. The first one is called systime.wday, which is some word from this structure. The move0 extension instruction is used to take this word and turn it into a dword before we pass it as an argument. The next number is systime.wmonths, which is another word inside the systime structure. The last argument is systime.wyear, which is a word inside the systime structure. After the call to printf, we exit the process. Maybe the most important thing to understand at this point about the program is the call to this function, getSystemTime. Somehow, using the call to this function, we managed to get the current time and also the current date. Let's check what MSDN has to say about this function. We go to msdn.com and next we search for getSystemTime. Now pick the first result. And we get this page which describes getSystemTime. The function has this syntax, getSystemTime, with one argument, LP SystemTime. It is specified that this argument is an output argument, which means that this argument is used to transfer data to the caller. This is where we have the result, inside this argument. As we can see in our program, the address of the structure is given to this function, which means that this function is going to take the address of this structure and write into the structure. As it knows the address, it can write to it, which means that this function is going to write into the structure. All it needs is to know the address of the structure. Let's keep reading the documentation. It says here that the SystemTime parameter is a pointer to a SystemTime structure to receive the current system date and time. A pointer is how high-level programmers call an address, which means that we do have to give an address as an argument to this function. It also says that this function has no return value, which means that EAX is not going to contain anything important. Maybe the important part about this page is this link to the SystemTime structure. If we ever want to use this function, we have to understand what is this struct. Let's click on this link. We got to a new page which describes the SystemTime structure. Here we can see the definition of the SystemTime structure. It is written in C++ syntax, but it is pretty much like the assembly syntax. Word means a data word, which is exactly 2 bytes. Every word here is given a name. The first word is called wyear. A good guess would be that this will contain the year. The next one is called months. Interestingly enough, there is also day of week. Day, hour, minute, second, and also milliseconds. In our program, we used the wday, wmonths, and W-year fields, as we only print the date to the user. You might be wondering, how come we have the system time structure inside our program? Or maybe, where is it defined? Where can we find the definition of system time? As we've probably guessed, this definition is somewhere inside Win32.8.inc. Let me show you where this structure is defined. This is FASMW, the directory where I installed FASM. I open the include directory and then the equates directory. Here I can find kernel32.inc. Let's open this file. Inside this file, many constants and structures are defined. Let's search for system time. And we can find it here. Let's compare it for a moment with what we have on MSDN. Note that this definition is exactly the same as what we can see in the MSDN documentation. Both of them begin with W-year and end with W milliseconds. Let's summarize this lesson. We have seen the getSystemTime function from kernel32.dll module. This function obtains the current time of the system in coordinated universal time. If you are wondering about localization, this is not the local time. This is the universal time. getSystemTime takes exactly one argument, which is the address of a system time structure. The result will be inside this structure. In this program, we use the printf function to print the date to the user. We just use the words wday, wmonth, and wyear from the system's time structure.